Welcome, everyone. My name is Nico Kabar. I'm joined by Ken Holden, Chief Architect at Red Hat, and today we'll be talking all things on visibility and troubleshooting modern applications with OpenShift and Calico. As I mentioned, I'm joined today with by Ken. Ken, you want to introduce yourself?
Sure. Thanks, Nico. Yes, Ken Holden from Red Hat. I'm Chief Architect for the Northeast Commercial Region, located in Delaware.
Thank you, Ken. Appreciate you joining us today for our webinar. As we do those webinars frequently, just a remind that we're going to be running about an hour. We'll have a variety of topics to cover as well as a demo. And if you have any questions, feel free to plug those in the Q&A section in Zoom here. Also a reminder that they will be recorded as well and be posted on our YouTube channel, as well as our events page in Tigera. So let's get started. In today's agenda, we'll be starting off with reviewing, Calico, quick overview of Calico and Calico Enterprise. Ken will help us with also a quick overview of OpenShift if you're not too familiar with it as the platform. And we'll discuss some of the networking options that you have on OpenShift, some pros and cons and some design considerations there. And then we'll switch gear to talk more on some of the key areas of troubleshoot and gain visibility into your applications that are running in OpenShift. And I'll have a small demo for you to showcase that. We'll leave some time towards the end for Q&A. So feel free to put those in the Q&A section, and we will be happy to answer them then. All right, with that, let's get started. So let's start with introducing Calico if you're not too familiar with it. So Project Calico started around the same time as Kubernetes. It's an open source, community-driven project aimed at creating a robust and performant networking stack and network security solution for Kubernetes workloads. So we from Tigera's perspective, we help maintain Project Calico, and it's widely adopted at this point. So some fun facts to why users out there are using Calico to power their networking for Kubernetes. It is blazing fast because it uses native Linux data plane capabilities and provides a layer 3 network for a flat network for your pods in Kubernetes. There is an option, of course, for encapsulation, but a lot of our users there are using using it in layer 3 without any encapsulation as well. It is massively scalable, built on the routing protocol of that is BGP. It's really the scale of Calico is same as scale of Kubernetes. So if you're the limit there is the Kubernetes number of nodes and pods and how you configure those and how you what your environment is that sets that boundary for your scale there. We have our partners from cloud services as well as other platforms and cloud platforms out there like AWS, Google, Azure, IBM have already standardized on and picked Calico for policy. It's already also been embedded in Docker Enterprise as well as Rancher, and of course, we have a strong relationship and partnership with OpenShift and the Red Hat team, and it's been integrated as an option for an operator-based option for powering OpenShift, and that's the core for our discussion today. In terms of real-world production use cases, of course, if you see there's many KubeCon sessions out there that reference Calico. We know of many customers out there and users out there that are running Calico at scale. We're aware of at least 150,000 clusters out there that are using Calico today. For Tigera, the company behind Calico, we maintain, as I mentioned, we maintain Project Calico. I also co-led some of the initial SEO security working groups and helped with that and kind of define the spec for both the CNI spec itself as well as the Kubernetes network policy spec. And we continue being involved in various SIGs within the cloud native ecosystem. In terms of our Calico Enterprise, which is a solution that we build on top of Calico, our Project Calico, where it adds a lot of the capabilities that are needed by a lot of the global enterprises today. And you can see here are a few of our top customers that are using Calico Enterprise today in production across various verticals. So I'll switch it over to Ken if you want to take the attendees for a quick overview of OpenShift and some of the design consideration from a networking perspective.
Ken? Thanks, Nico. Go ahead and go to the next slide for me, please. So what is OpenShift? The concept of microservices has taken off as developers understand the reasons to break apart large monolithic applications into the smallest forms so that they can rapidly develop and produce new features. Building a microservices platform, though, isn't simply just running Kubernetes. Everybody's heard of Kubernetes. We kind of know what it does, but it's a small portion of what you need to run that full platform. A microservices platform requires a method to quickly deploy and maintain the environment, from the operating system to Kubernetes to the networking, storage, logging, metrics, and the developer tools, so that developers and operators can get up and running quickly and consistently across wherever they're running it, whether it's in their data center or in the public cloud. So Red Hat OpenShift is a Kubernetes platform, but it provides a trusted foundation for that on-premise deployment as well as into the hybrid and multi-cloud environments. It's a collection of open source tools that makes up the application platform, which allow you to run containerized workloads on bare metal and virtualized environments, both on-premise and in the cloud. An application platform needs to provide a consistent way for both the developers and the operators to collaborate across the deployment footprints from edge and air-gapped environments to the infrastructure that you have in your own data centers, as well as utilizing public cloud providers. OpenShift is the platform that allows you to achieve this. Can you go ahead and advance to the next slide, please? So with the foundation of a trusted enterprise Kubernetes platform, we add enhancements to deliver an application platform with all of the components you need that are fully integrated to build, deploy, manage containerized applications. In many ways, it's a smarter Kubernetes platform. It allows you to streamline the installation and upgrade experience. You can get up and running with a fully configured Kubernetes cluster using OpenShift in less than 15 minutes with everything you need that has metering, monitoring, application, and developer services. And when it's up and running, Kubernetes updates, security patches, the components, updates, it can be deployed with a single click. This is one of the challenges if you've ever deployed Kubernetes by yourself, as well as all of the logging and metrics and monitoring services that go along with it. Having the ability to quickly do it, automated wise, and then quickly click a button and have it update in place is a huge advantage. It's based on RHEL Core OS. OpenShift can actually update the underlying operating system and scale at the node level. And this is particularly useful when you deploy OpenShift on a cloud infrastructure, because the entire cluster can scale up and down based on your application needs. And this allows you to scale easily from tens of containers to 10,000 of containers and then back down again based on your needs. Looking at this diagram, Kubernetes is only one component of this entire microservices platform. With OpenShift, we start with the operating system, and this is your foundation, which this is supported to run on bare metal on virtualized environments, as well as all major cloud providers. And next we see the Kubernetes piece, which along with the container runtime forms your orchestration layer. And then moving up the stack are cluster services such as automated ops, over-the-air updates, monitoring, container registry, networking, virtualization, and even Helm. And then we get into the platform, application, and developer services layer, which provides things like service mesh, CI/CD pipelines, logging, chargeback, runtimes, business automation, and developer tooling. And then lastly, the multi-cluster management that gives you the ability into multiple Kubernetes clusters, as well as policy, compliance, configuration, workloads deployed to those clusters. What we've seen from customers is that one Kubernetes deployment isn't really enough. You're going to have them deployed in your data center, on-prem, maybe on bare metal, maybe on virtualized environments or multiple virtualized environments. And then you're going to span out to public cloud, maybe one cloud provider, or maybe diversifying your cloud footprint across multiple providers. So being able to have the ability to deploy rapidly and manage multiple environments is key. Can you go ahead to the next slide, please, Nico? So another feature that's added with this is Red Hat OpenShift includes a SaaS-based management console that allows you to register your existing OpenShift clusters as well as provision new ones. And you get the comprehensive visibility across all your clusters from a single pane of glass. There's also, in this new service, it can be found at cloud.redhat.com. From there, you can see your existing clusters, deploy new ones, and with a single click, perform in-place upgrades. So it's pretty slick. The SaaS offering that's included with OpenShift is an evolving offering. So there's what it can do today, which is the visibility, see some metrics, do the in-place upgrades, and deploy new ones. But more features are being developed and will be coming in the future. And one other note, we've added a newer product called Advanced Cluster Manager. What this allows us to also deploy and manage Kubernetes clusters, but it also provides application deployment, management, and governance across all of those clusters. So you can determine where applications go, how big a cluster might be in one environment versus another, and so forth. So let's skip to the next slide, please. So now we've kind of understand the basics of what OpenShift does. Let's talk about the OpenShift networking components that is included with it. So OpenShift uses a software-defined networking, or SDN, approach to provide a unified cluster network that enables communication between pods across the OpenShift cluster. OpenShift networking abstracts away the physical equipment and cables of traditional network infrastructure by way of this SDN. The container SDN is referred to as an overlay network as it sits on top of the underlayer of the physical. The overlay network provides all of the connection endpoints and connectivity between containers, pods, nodes, virtual switches, and routers, and the underlay network. So when Kubernetes needs to add a container, or delete a container for that matter, it coordinates the networking changes with the overlay. This is also how you would expose your applications to the outside world. Can you move forward, please? So OpenShift out of the box offers two choices for the container native interface, or also called the CNI. OpenShift SDN and OVN Kubernetes. OpenShift SDN is based on Open vSwitch, or OVS, and is the supported default currently in OpenShift. OpenShift's next gen SDN, which is called OVN Kubernetes, is an open source implementation of OVS that adds native support for virtual network abstractions, such as virtual L2 and L3 overlays, and security groups, supports multiple tunnel overlays, including Geneva and VXLAN. And this is currently in tech preview. That means that the bits are provided in OpenShift currently, and there's documentation for how to get started on it. But it's not currently supported at this time. Its release should be pretty soon as a supported component. OpenShift also supports third-party CNIs to offer even more network functionality beyond what OVS and OVN can provide. This is where Calico Enterprise and Red Hat OpenShift work really well together to give you that full enterprise-ready solution from both the containerized platform as well as the advanced networking features. Skip to the next slide, please. So to support different networking use cases, OpenShift SDN provides 3 modes for configuring the pod network. The network policy mode allows project administrators to configure their own isolation policies using network policy objects. These network policies, this is the default mode in OpenShift container platform today. The multi-tenant mode provides project level isolation for pods and services. Pods from different projects cannot send packets to or receive packets from pods and services of different projects. And you can disable this isolation for a project, allowing it to send network traffic to all pods and services in the entire cluster and receive network traffic from those pods and services as well. Lastly, the subnet mode provides a flat network where every pod can communicate from every other pod in the service. Go to the next slide, please. So lastly, I'm going to talk about challenges that network administration or network administrators may face when looking to support microservices in production. Network admins might be newer to overlay networking. They may be familiar with it, but not with how to troubleshoot networking from within the Linux operating system. Troubleshooting an Open vSwitch, for example, via command line is not trivial. Especially for those not experts in Linux. And even the people that are experts in Linux, the command line tooling is immense. And so out of the box, OpenShift SDN and OVN Kubernetes lack visibility tools outside of the command line for what's happening at a lower level. Like for example, a simple operation like running a TCP dump on an interface that many of us are familiar with becomes challenging because now you're dealing with OVS and namespace-based networking. Which for some that you might be unfamiliar with. Other common asks from customers are for advanced networking features such as BGP to eliminate double encapsulation, as well as east-west traffic encryption and enhanced egress rules. Another common concern I see is having some guardrails in place to prevent accidental disruptions. Out of the box, OpenShift has some powerful networking capabilities, but some might be concerned about changes that they make that could cause a disruption. Having the ability to visualize the policies that you want to deploy and test them out before actually making them active, as well as being able to see what policies are actually seeing traffic currently, can be extremely helpful. And that will help network administrators from causing disruption and make them a little bit more at ease with the product. For this, Red Hat supports the integration of Calico Enterprise from Tigera to address this. And so that's where Nico is going to go take over from me. That's all you, Nico.
Thank you, Ken. Sorry, I was muted. Thanks for that. So as Ken mentioned, there's a lot of value in if you're standing up OpenShift or planning to stand up OpenShift for deploying your modern applications, whether on-prem or in the cloud. It comes with an out-of-the-box solution, but if you need more than that, this is where Calico can be a huge value-added solution to help you and enable you to gain a visibility into your application networks, as well as help you troubleshoot those applications. Now we'll switch gear into focusing more on that. This is a good summary, of some of the features and functionalities that Calico can help address, or the gaps that it help address that are not available out of the box with the built-in solution from OpenShift. To name a few, advanced network policies that go beyond with from the basic Kubernetes network policies. Calico has an extensive set of what we call a superset of functionalities to define more advanced network policies. Application layer policy integration with Istio and Envoy. DNS and egress access controls to allow certain pods to specify egress rules to allow them or deny them access to DNS-based or domain-based egress objects or destinations. We also have recently added support for multi-cloud and even multi-cluster federation for both identity as well as policy. So as you scale your OpenShift deployments, Calico can help you decrease the operational complexity of managing multiple clusters and multiple policy workflows there. Of course, everything is R-backed and with detailed audit trail and audit reporting and continuous compliance reporting for all things networking within your environment. So those are kind of a few areas where Calico can help with your OpenShift. So we added a couple things recently in the past 2 to 3 quarters, especially working closely with OpenShift teams around kind of the simplicity of the installation, especially with OpenShift 4.x. It's really straightforward to install Calico, really out of the box installation when you use the OpenShift installer. There's integration with OpenShift for auth and OIDC. And of course, the RBAC is all tied into your existing RBAC for auth and LZ of OpenShift itself. And you can continue using your favorite either kubectl or OC command line for for operating or managing all things related to Calico within your OpenShift environment. So why are I want to kind of double click on some of the specific use cases that, as Ken mentioned, they actually shared some of the few use cases in which actual customers have raised around some of the capabilities that Calico had helped them with, or looking for Calico to help them with. So I wanted to kind of take a minute to summarize that in using this slide. So out of the box, we have a tool called Calico Kettle that client-side tool that has extensive functionalities to interact directly with Kube API and etcd to manage all things related to configuring your networks, what we call IP pools, like segmenting your networks to different subnets and different configurations, and some of the advanced networking features can be managed through that tool. Calico itself provides various networking options, right, that go beyond what's built in with OpenShift around both, if you want to have a flat layer 3 non-encapsulated network that is tightly integrated with your VPC or with your underlay network, you can do that with Calico. We have a few customers who are actually actually more than a few customers who are peering directly into their networks, and that way they have removed the overhead of any encapsulation, but also provide both the XLAN based as well as IP/IP based encapsulation. There's a lot of use cases for those as well. Many of our customers are actually asking or have access or use some of the advanced networking capabilities like topology aware IP address management. If you want to assign certain pods or in certain namespaces, certain IP addresses, and also pod and service advertisements. So if you want to advertise pod IPs and routes directly, prefixes directly into your network, that's also something that you can easily do with Calico. I mentioned around kind of peering options. If you want to peer directly with your network or your VPC, you can also do that with Calico. In terms of network security, network policy enforcement, Calico is can enforce your policies, both Kubernetes network policies as well as what we call Calico network policies, which have advanced capabilities like global-based policies, ingress and egress policies, DNS-based policies, and even the layer 3 through layer 7 identity-based integration with Istio and Envoy. If we look at kind of the low-level performance focused kind of enhancement that we've been working on. You have out of the box 2 modes with kube proxy around kind of load balancing services to pods with IPVS or IP tables. We support both options, as well as we've been working a lot on releasing, and now we're GAing with a new data plane option. So this traditional one is IP tables, but there's also eBPF support natively with Calico right now, and we actually were working closely with the RHEL team to enable that with RHEL 8 as well. And for those who are using or plan to have to use Kubernetes with Windows-based workloads, Calico is one of the few options that you have in terms of a consistent CNI that works both across Linux-based environments as well as Windows-based environments and workloads. So this is a kind of to recap why Calico can truly power your OpenShift deployment. Some of the key areas of why some of our users and customers are using today. So let's switch to the visibility and troubleshooting. Now that we kind of talked about OpenShift as an overview for in Calico, and we talked about some of the network design and consideration and why Calico can help you. One of the key areas, and it's kind of the core discussion for our session today, is around visibility and troubleshooting, because it's basically one of the key areas that a lot of customers go through and a lot of users go through as they onboard their applications. Especially if they're moving from a monolithic-based application to microservice-based application. Once you start doing that, seriously, the network becomes a really, really important component, a foundational component, not only to provide that as a kind of robust foundational kind of infrastructure, right, for your microservice application, but also the tooling around the visibility for all things networking to manage communication between the microservices and better understand how they're behaving and come to resolution if you're seeing any issues with them. So this is where kind of the importance of Calico Enterprise come in with the advanced functionalities for visibility and troubleshooting can really help you there. So the problem that we see a lot of users face is around kind of connectivity issues, with microservices. There's that can result in a downtime, and of course, the downtime can be expensive, both from can be costing actual money for a lot of our customers today. If their certain mission critical application goes down, they can quantify the cost associated with any downtime. So, avoiding any downtime is especially when it comes to networking-induced issues, is critical. Of course, the platform teams here, they need to, way to pinpoint the source of any connectivity issues, network-related issues, and avoid try to resolve them and avoid connectivity issues well in advance, and plan around those as well. And a lot of our users have been telling us, like, when they are onboarding applications to Kubernetes, as they learn around the process, start designing their environments. When it comes to networking and network security, they feel that they're flying blind. And this is where we can come in and help with those 3 key areas around monitoring. We provide monitoring tools to help with the overall state of the network, help with troubleshooting as well, and overall visibility into advanced data collection around all things related to the pod network in your Kubernetes cluster. So one of the ways we do that is by, first and foremost, we gather advanced flow logs that go beyond beyond what any other existing flow log and flow log management tool can capture. So we have advanced metadata around the pods and services and namespaces for every flow log. And we capture that and we store that, and you can actually export that into your favorite logging tooling to report incident and so forth based on that. But the core, the key thing to remember is that we capture much more advanced flow logs for every flow that touches any pod, whether it's east to west traffic or north south traffic. One of the ways we use that data, those flow logs, is this easy to use visualizer that helps not only just admins but also teams themselves to actually figure out what's going on within their environment, for their namespace or project, and try to understand if there's any issues and pinpoint issues and right away from this visualizer. Next area is I've spoken with a lot of users out there who are hesitant to use network policies. They see the value of network policies, but one of their points or challenges around that is they don't understand how to operationalize, creating and managing those policies. So there's nothing really out there today to help with that. I mean, you can create policies, but the challenge is, like, you don't understand the impact of the policy before you apply it. You don't understand if the policy is doing what it's intended to do, you understand kind of the full authorization of who can and who can create policies, who can adjust them, and so forth. So what we put forward with Calico Enterprise is a framework to help you and your teams as you scale to create, stage, enforce, update, and kind of overall do day-to-day management for your policies using either the GUI or standardized API around it. We also offer easy-to-use recommendation engine for policies that collect data around your application and kind of suggest policies based on that data. Also, we help with identifying the impact of any staged policy before you actually enforce it. So if you can think about it, it's like an SE Linux in non-enforced mode. If you want to collect certain data and understand the impact of the policy before you actually apply it to avoid any downtime or unintended impact for applying the policy, Calico Enterprise can help you with that as well. So to summarize what some of the capabilities provide, Calico Enterprise provides end-to-end visibility to your workloads running on OpenShift. We provide Kubernetes and context-rich flow logs that you can use and go back for either real-time analysis or even go back in time to fully understand and report on certain events or incidents, as well as network policy workflows to help mitigate some of any issues and avoid them at all costs. So with that, let's do a quick demo of Calico Enterprise on OpenShift, and then we'll switch to some final notes and leave some time for questions. So a quick kind of note here is that we have a OpenShift cluster right now running with Calico Enterprise, and I have this application that is called Storefront. You probably, if you attended any of the sessions before, we use this and overuse it, I think, this application. But this time we're running a project that's called Storefront, and there's some microservices running in there. And we're going to take a look and understand, we're seeing some issues around DNS. The focus and the value here of using Calico Enterprise, especially on OpenShift, is that we can provide the tooling around, if certain issues are happening or there's any reports of certain issues, the tooling around networking related network visibility is going to be from Calico Enterprise is going to be really helpful. So we're going to take a look at that. Right now. So some of those services are reporting DNS related issues, so we can take a look at them right now. Hopefully you guys can see my terminal. So I have, as I said, we have pods running in the Storefront namespace right now. And if we take a look at our OpenShift dashboard, we can see here that under the workloads, we have, if we look at Storefront, you can see that all their pods are currently running and they're functional across a couple of worker nodes. Let's take a look. If you haven't seen the Calico Enterprise itself, this is kind of the dashboard for Calico Enterprise itself. You can see as a quick overview, just a histogram of all things, all the stats that are happening across your network. We can already see some red flags here on some denied packets, for certain workloads. But this is the dashboard that comes out of the box with Calico Enterprise to showcase what's going on across all your workloads. If we take a look at the policies, this is an easy to use dashboard for what we call a tiered policy approach. So tiers can provide a mechanism to standardize on more critical policies that are going to be uniformly applied across your projects within your cluster. So you can align certain security team to create their own sets of policies that would be evaluated first before any of the application or app dev policies are enforced. If we take a look at just an example here of the this Twilio integration policy. It's an easy to use UI to manage the policy and make any changes and view those changes directly from the UI. Finally, I want to showcase the flow visualizer, which is what I discussed earlier around easily visualizing what's going on in the cluster. Of course, when you look at it at first, it's maybe looking complex, but you can see here that the outermost layer is showcasing or detailing the namespaces, and the middle layer is the services, and the innermost layer is the pods. And you can see already a flashing light there showcasing there's some some issues with certain traffic. So if you look at the status mode, and you can see here that there's the denied traffic just by looking at the flow visualizer that is going on. If you look at it, you can see here that there is if we look at all flows, we can see that there's some of the flows that are red. We can see that the front end service that's trying to access DNS default service that's being blocked. We need to investigate why that is the case. We have microservice 1 and microservice 2 also reporting similar issues. So by just viewing this at a high level, we can see that there's issues from it even before the application reported that here. So if we take a look, it seems like we have another mechanism to dig deeper, which is the built-in advanced flow log. So this is what I'm going to jump to right now. Out of the box, we provide a easy to use dashboard to look at the actual advanced flow logs, and we can see here that over the past, let's say 15 minutes or so, we're going to take a look at all the denied traffic, and if we look at any of the entries, we can see them here. You can see that there's the JSON format as well as the table format of the metadata that we get from every flow log here, and we can see this is the action was denied. So I was able to quickly search on the denied traffic, and I can see all the metadata that would help me try to understand what's going on here. So things like the namespace, the pod label, for source and destination, the IP address, and specifically I'm interested in the actual policy. It seems that this policy that has been denying this traffic, and this is TCP traffic going to DNS, resolving DNS, and that's why we're seeing some of those issues. And it seems that we're pointed to the specific policy that is actually denying this traffic. So if we take a step back, by just looking at one advanced flow log entry, we're able to highlight a couple of things: the metadata around the flow log itself, the action that was denied, what was the intended destination of this traffic, and the policy that is causing this issue. So if we take a look, it seems that this specific policy is denying this traffic. We actually had already certain policies that are basically providing some zoning for the microservices, and it seems like it's not allowing DNS to actually pass through to access the OpenShift DNS service that comes in by default. So one of the ways we can actually resolve this is right now we have allow kubedns policy, but it seems that it's only allowing it for the Kubernetes kubedns, which is not the default in OpenShift. So this is an example of once we understood the source of the problem, it was related to a policy that is denying the DNS traffic. It is denying it for all the traffic that's headed to the OpenShift DNS services, and it seems like there's no policy or rule that is explicitly allowing that. So let's go ahead and add that real quick. We're gonna add all the protocols right now. We're gonna do we're gonna go to just add that. So this is the label of the DNS DNS service from OpenShift itself. So by just allowing this, we can save the rule. But before we apply it, one thing we can do is actually try to test it out. So if the preview would actually help us understand. In the case we actually are blocking traffic, the preview functionality would tell us what it would be blocking. But oops, I'm not sure what's going on here. Unfortunately, I don't know why that did not work. But what we have done here is actually just add this rule that would allow not only traffic to go to the Kubernetes DNS, which is not the case when we are installing, when we're running OpenShift, to the OpenShift default DNS. And once we can stage this policy to get advanced telemetry, but we can also enforce it to see it in action. So once we do that, we can, of course, go back to the Kibana and see that there's not any traffic, but we can also look at the flow visualizer and hopefully at this point change the time range to, let's say, 3 minutes maybe. Hopefully we'll stop seeing those blocked traffic. This probably needs some time to refresh. But just by doing that, we're able to allow the DNS-based traffic to pass through, and we were able to highlight the issue just by looking at a flow visualizer and seeing that the core of the issue, or the cause of the issue, out of the box. Let's see if I'm going to give it some time here for it to take refresh and see. While we do that, let's summarize the discussion here, and I'll come back to the demo to showcase the last step. But just for additional resources for you guys, feel free to always head to Tigera IO/partners and Red Hat. We kind of summarize all the things related to our collaboration with the Red Hat and OpenShift teams all in one place, white papers, documentation, and so forth. So this is a great resource to have. We also have a Calico Enterprise trial that is hosted. So if you haven't played with Calico Enterprise and you want to test it with OpenShift, if you head to the site, we actually provision an environment for you where you can actually test end-to-end Calico functionalities, the one that we saw today on OpenShift. Finally, we have a lot of events coming up over the next couple of weeks. So head over to Tigera IO events, and you can see what's coming up, maybe something of interest for you. With that, I would like to kind of thank Ken for joining me today, and would like to open it up for questions if you guys have any.
Yeah, and I'd also like to add, you can go to try.openshift.com as well.
Yep.
If you want to try out OpenShift. I totally spaced on leaving that slide in there.
No worries.
Yeah, try.openshift.com. You can spin up an environment very, very quickly.
Thank you. Maybe I should open up. I'll remove. You guys can unmute yourself since we have like 12 minutes or so. Let me see. So you're allowed to unmute yourself. If you have any questions, feel free to kind of unmute yourself and speak up, or plug in if you cannot speak up, plug in the questions in the Q&A section in this. Quiet group today.
I mean, that flows demo is case in point. Looking at, if you ever worked with Open vSwitch, or OVN for that matter, when you need to dump flows, it is challenging, to say the least. So to have that visualizer is probably one of the coolest features from the very nerdy side of troubleshooting this type of stuff. The visualizer is pretty cool looking, but that flows stuff is slick.
Yeah, thanks, Ken. Those are based on probably your feedback you're getting from working with different OpenShift users today.
Yep, and having to troubleshoot it in the past. So,
yeah, not fun. Not fun. Yeah, I mean, combining the visualizer, of course, it's not just going to solve word hunger. First, it's going to be a good starting point. One thing I forgot to mention is that, of course, we don't expect folks who are operating OpenShift to just sit down and watch it, visualize it, and just hope to see any issues. But everything that you've seen here we have an event or alert based system where you can actually trigger certain alerts if certain policies are seeing certain or blocking certain traffic, and you can integrate it with your existing alerting system as well.
And I mean, one of the things we see quite often is, developers pick a platform. So they go with OpenShift, they build their applications for it. It's working great in dev, and they want to take it into a production world. And now the NOC has to take over, or the ops staff. And all the tools that they're familiar with using, all of the technologies that they're used to, this is completely new to them. So if you're planning on taking on this type of thing, figuring out how you're going to do that before you start building it is extremely important. So getting aware and becoming aware of Calico and OpenShift and how they work together before you start is certainly recommended.
Yeah, great point, Ken. Any questions from the audience today? Going once? All right, if there's none, thank you folks, appreciate the time, and thank you so much, Ken. Again, the video will be posted online on YouTube, so hopefully we'll see you again. Thank you.